Well, good afternoon, guys. It's going to be Thursday, November 6th. I should be back probably next week, hopefully. I look forward to seeing you guys. But this is going to be the last section that we're going to be covering in Chapter 11. If you guys remember back in 11.1 and 11.2, we've just been kind of introducing to some of the basic sequences and series. 11.1 was just an introduction. 11.2 was really more of the arithmetic, which remember you were adding or subtracting the same number each time to get to the next term. All right, so in this last section, we're going to look at geometric sequences in series, which instead of adding and subtracting the same number each time, you're actually going to be multiplying by the same number each time. All right, now if you remember before when we were doing arithmetic sequences in series, we had that common difference, that number that you were adding and subtracting. This time, that number that we're multiplying by is going to be called my common ratio. All right, so let me just go through. So right here, we've got our common ratio. So that's that number that you're multiplying by each time to get to the next term. So if you kind of scroll down here and look at what common ratio is, the ratio of successive terms in a geometric sequence. It's always the second term divided by the first term. Always, always, always. So if you're looking at a set, sometimes you can tell, oh, obviously I'm multiplying by this number each time. But sometimes, like in this example right here, it's hard to tell. All right, so what you want to do then, to find that common ratio, you take your second term, which in this case would be 2. You take your second term and divide it by your first term, which in this case would be 10. So 2 divided by 10, which reduces to 1/5. So you could say your common ratio here is 1/5, or if you wanted to call that a decimal, be zero point 0.2. Because it's a finite decimal, it's okay that we call it 0.2. So your common ratio here is 1/5 or 0.2, which means 10 times 0.2 is 2. 2 times zero point 0.2 is 0.4 times zero point 0.2 is 0.08, etc., etc. So here you're multiplying by the same number each time. In this case, my common ratio is 0.2 or 1/5. All right, so let's look at a couple examples where we're determining whether or not, or what the common ratio is. All right, so right here. All right, so if I'm starting, my first term is 21, so we'll call that a sub 1. Remember, that means my first term, 4.2, is a sub 2, a sub 3, etc., etc. So my first term, second term, third term, etc. All right, so what I want to do is find the common ratio. Now, just by looking at this, I have no idea how I get from 21 down to 4.2 by multiplying by some number. So this is where it comes in, or makes it easy if I just take my second term, which is 4.2, and divide it by my first term, which is 21. So my second term divided by my first term, if I take that and I plug that into my calculator, I get 0.2. All right, so here my common ratio, again, just like that example we just looked at, is 0.2, which means if I took 21 and I multiplied it by 0.2, I get 4.2. If I take that and multiply it by 0.2, I get 0.84, etc., etc., etc. So it also asks us first not just only to find the common ratio, but then to find the next three terms. So to find my fourth term, I take my third term and multiply it by zero point 0.2. So if I take 0.84 and multiply it by 0.2, I'm going to get 0.168. So that's my fourth term. My fifth term, if I take 0.168 and multiply it by 0.2, I'm going to get 0.0336. All right, so that's my fifth term. And then my sixth term, same thing. If I take 0.0336 and multiply it by zero point 0.2, my sixth term, or the third term that I needed to find, is 0.00672. All right, so again, I'm multiplying by zero point 0.2 each time to find the next successive term. All right, so my common ratio here was 0.2, and then to find my next three terms after that, which is my fourth through my sixth term. All right, so let's look at another example real quick. This one's going to be a little more tricky. It's a bit more tricky. All right, so my first term is 2t minus 10. My second term is negative 4t plus 20. My third term is 8t minus 40. So if you guys notice, I've got a variable in here and I'm adding a number to it, so it just looks a little confusing. All right, but I still want to find my fourth term, my fifth term, and my sixth term. All right, so let's go through and find each of those. So first, let's find my common ratio. Now, again, just by looking at it, I have no idea. All right, so let's go through and let's take my second term, which is negative 4t plus 20. Negative 4t plus z20. And we'll divide that by my first term, which is 2t minus 10. Now, just by looking at these, you got to be very careful. You can't just take the 20 and divide it by -10 and get -2 and then -4t divided. So you can't just do that. You have to factor out something, whatever they have in common. So if I look at my numerator, I can factor out a -4. So from the -4t and the 20, I can factor out a -4. So let's factor out that -4. And I'm left with, if I factor out a -4, I'm left with t. 20 divided by -4 is -5. All right. Now what about my denominator? All right. If I can factor out a 2 from that, so I've got a 2 times t minus 5 once I factor out that 2. So there we go. Now if you look at this, my t minus 5s are actually going to cancel. So I'm left with -4 divided by 2, which simplifies to be -2. So that's actually my common ratio. So what that means is if I took 2t minus 10 and I multiplied by a -2, I would get -4t plus 20. So 2 times -2 is -4, -10 times -2 is +20. So that means I'm multiplying each of these terms by -2. So let's go through and let's just see if we can find my fourth term. All right, so I take my third term and multiply it by -2. So what do we get? So -2 times 8t is -16t. -2 times -40 is +80. So my fourth term is -16t plus 80. All right, well, let's find my fifth term. Same thing. I'm going to take my fourth term and multiply it by -2. So we'll just go through. So -16t times -2 is +32t. 80 times -2 is -160. So that's going to be my fifth term. I'm going to find my sixth term. I take my fifth one and multiply it by my common ratio, which again is -2. So we take that, multiply by -2. So 32t times -2 is -64t. And then -160 times -2 is going to be a +320. Cool. So again, each term I multiply by -2 to find the next successive term. So I took my fourth term, I multiplied my third times -2. To find my fifth, I took my fourth term times -2. To find my sixth, I took my fifth term times -2. All right. So again, geometric sequences means in order to find that next term, I have to multiply by that common ratio. All right. So let's look at our next example. So it says show that the sequence is geometric. So I've got to show that there is in fact a common ratio. All right. And then it says find the common ratio and then write out the first four terms. All right. So first what I want to do is let me just find my first four terms since that's what they're asking for. And then once I find those first four terms, I'll use those to make sure I do in fact have a common ratio, which means it's geometric. All right, so let's do that. So let's change the color. So let's first find my first term. All right, so remember to find your first term, you plug in a 1 into your n value. So this will be 2 raised to the 1 minus 1 all over 4. All right, so that's going to be 2 to the 0 over 4. Remember, anything to the 0th power is 1, so that's going to be 1/4. So there's my first term. All right, so now let's keep going. Let's find my second term, my third term, my fourth term, etc. And let's just make sure this is, in fact, going to be geometric. So to find my second term, remember, a sub 2, my second term, I plug a 2 into my n value. All right, so we'll go 2 raised to the 2 minus 1 over 4. Well, 2 minus 1 is 1, so this is going to be 2 to the first power over 4. Well, 2 to the first is 2, so it's 2 over 4, which reduces to 1/2. All right, on my third term. Boom. All right, so my third term, same thing. To find my third term, I plug in a 3. So this would be 2 raised to the 3 minus 1 over 4. Well, 3 minus 1 is 2, so this would be 2 squared over 4. 2 squared is 4. So we've got 4 over 4, which do be 1. Okay. All right, so let's find my fourth term real quick, and then we'll go through and we'll make sure that these are, in fact, representing a geometric sequence. So, find my fourth term, same thing. Let's plug in the 4. All right, so 2 raised to the 4 minus 1 over 4. 4 minus 1 is 3, so I've got 2 cubed. Wow, that's not over 8, actually. There we go. All right, so it's 2 cubed over 4, which is going to be 8 over 4, which is in fact 2. All right, so now what I need to do is figure out what my common ratio is and make sure that that ratio occurs between all of my successive terms. All right, so to do that, we'll take my second term, which is 1/2, and divide it by my first term, which is 1/4. Now we've seen this kind of occurrence before. Anytime we have a fraction divided by a fraction, remember the easiest thing to do is to multiply by the reciprocal of the denominator. So I'm going to take 1/2 times the reciprocal of 1/4 is 4 over 1. Right? This means you take it and you flip it. So that gives me 4 over 2, and 4 divided by 2 is 2. All right, so it looks like my common ratio is 2. So let's just make sure. 1/4 times 2 will give me 1/2. 1/2 times 2 will give me 1. 1 times 2 will give me 2, etc., etc., etc. So my fifth term should be 4, all right, because I take 2 times 2 is 4. My sixth term should be 8, because 4 times 2 is 8. So it looks like my common ratio is 2, so this does in fact represent a geometric sequence, and my common ratio is 2, and there are my first 4 terms. Awesome. All right, so now just like we have with arithmetic sequence, we kind of have an equation that we can use to come up with that general function, that general representation to find my nth term of a sequence, all right? So let's look at that real quick, all right? So similarly to what the arithmetic one was, this is what I'm going to use to find the nth term of a geometric sequence. Now notice I don't have a common difference here because it's not arithmetic. I've just got my common ratio because it's geometric. So R represents that common ratio. So A sub n, so whatever term you're looking for, is equal to your first term times your common ratio raised to whatever term you're looking for minus 1. All right, so let's just look at that and just start jumping in and find some examples. All right, so it says find the ninth term in this particular sequence. All right, now they don't tell me it's geometric. Now I know it is geometric, so let's go ahead and let's find my common ratio first. All right, so my common ratio, remember we take my second term, which is 9, and divide it by my first term, which is 10. All right, so 9 divided by 10 will give me 9/10. All right, if you want to call that 0.9, that's perfectly fine. All right, but we're going to call it 0.9 or 9/10. So that's my common ratio here. So now I can go through and I can find my ninth term. So because I know it's geometric, I'm going to use this particular function to find my ninth term. So we're looking for my ninth term, so it's a sub 9 equals my first term, which is 10. So 10 times my common ratio we said was 0.9 raised to the n minus 1. Now since I'm looking for my ninth term, this n value here is going to be 9. So it's going to be raised to the 9 minus 1. All right, so we got a sub 9 is going to equal, let's just take this step by step. 9 minus 1 is 8, so it's 10 times 0.9 raised to the 8th power. All right, so we're just going through, simplifying each step. Now 0.9 to the 8th power, let's write this out. So a sub 9 is going to be 10 times 0.9 to the 8th power is approximately 0.4304. Cool. And that means that my ninth term, 10 times 0.4304 is going to be 4.304. And there you go. So the ninth term of this particular geometric sequence would be 4.304. You could convert that to a fraction if you wanted to, just using your calculator, but that's going to be the ninth term of my sequence. All right, so I want you guys to take a quick second. I want you guys to try the next one. So Mrs. Miller, if you don't mind just pausing it here, and you guys can work through it, and then once you guys are ready, you just hit play. All right, so let's find the 12th term in this particular sequence. All right, so again, we're assuming it's geometric. Later on, when you guys get to the tests and reviews and stuff like that, it'll tell you find the 10th term or 12th term of the geometric sequence, so you guys know whether it's geometric or arithmetic. All right, so I know that this one's going to be geometric, so let's find that common ratio. I'm going to take my second term, 26.4, and divide it by my first term, which is negative 24. When I do that, I get my common ratio to be negative 1.1. All right, so now I'm looking for a particular term, so I'm going to use that equation that we just looked at. So I'm looking for my 12th term, so it's a sub 12 equals my first term, which is negative 24, times my common ratio, which we said was negative 1.1 raised to the n minus 1. Remember, by the 12th term, I'm looking for my 12th term, so that my n value is 12. Be 12 minus 1. All right? So the first step, just plug everything in. Next thing, we'll start simplifying. So I've got negative 24 times. So 12 minus 1 is going to give me 11. So we're going to have negative 1.1 raised to the 11th power. All right? Now, when I take a negative 1.1 and I raise it to the 11th power, I'm going to have negative 24 times, it comes out to be about approximately negative 2.85. All right, so negative 2.85 times negative 24 is going to give me my 12th term to be approximately 68.47. Cool. There you go. So my 12th term is approximately 68.47. All right. Cool. All right. So let's look at the next example. So those first two, they're asking for a specific term. So I use that equation to find that specific term. Now what we're going to look at is an example where they want me to actually find the first term of my particular geometric sequence. And I know it's geometric because they're giving me an R. So R, remember, represents common ratio, which means it's a geometric sequence. They gave me the common difference, which would have been D, then I would have known it's arithmetic. Because they give me R, I know it's geometric. All right? So I know my common ratio. So let me just write out what my equation is because I know it's a geometric sequence. So it's my first term times my common ratio raised to the n minus 1. So I'm actually looking for my first term, which is this piece here. All right, so that's what I'm looking for in this case. So I'm not looking for a specific term. Now, they give me a specific term, so I want to use that. I want to use my common ratio to find my first term. So they give me my fifth term, so what I'm going to do is I'm just going to plug in a sub 5 equals my first term I don't know, that's what I'm looking for, times, I know my common ratio is 2. Now if they give me my fifth term, that means my n value is 5. So it'll be 5 minus 1. Alright, now, because they give me my fifth term, a sub 5 is 24. So what that means is I can take 24 and I can substitute that into a sub 5. So I've got 24 equals a sub 1 times 5 minus 1 is 4, so this is 2 to the 4th power. All right? So when I go through and start simplifying, 24 equals a sub 1 times, so 2 to the 4th power is 16. So it's a sub 1 times 16. So just like if this a sub 1 were an x or a y, to solve for that variable, I've got to get rid of this 16. I got to get the variable by itself. So since I'm multiplying here, the opposite of multiplication is division. So I'm going to divide both sides by 16. So cancel that. Divide by 16 on that side. All right, you can simplify it as a fraction. If you do, your first term is 3 over 2. Or you could write it as a decimal since that's a finite decimal, so 3 over 2 or 1.5. So similar concept. They wanted me to find the first term of my geometric sequence. So I just kind of plugged in the pieces that I knew and I solved for the part that I need. All right, so same thing. Cool. All right, so what I want you guys to do is I want you to try and do this next one on your own. So if you don't mind, Miss Miller, just pausing it here, and you guys take a quick second, a quick couple minutes to work on that next one. All right, so once again, trying to find the first term of this particular geometric sequence. And again, I know it's geometric because they say, hey, your common ratio is this, which again means I've got a geometric sequence. So because it's a geometric and I'm trying to find a specific term, we're going to go through, we're going to use this particular equation. So my first term times my common ratio raised to n minus 1. So once again, I'm trying to find my first term. A sub 1 represents my first term. So that's what I'm trying to find. So that's where my variable is, which means I should have something here, and I should have everything filled in here. All right, so they give me my fourth term is 2.5. So I'm just going to substitute. So we got A sub 4. I don't know my first term, times my common ratio is 2, raised to the, I know I've got my fourth term, so my n value is 4 minus 1. All right, so let's go through now. Because I know my fourth term is 2.5, I can take that and I can substitute into A sub 4. So A sub 4 is 2.5. That's my first term, times, so 4 minus 1 is 3, so this is going to be 2 cubed. All right, so let's go through and just simplify a little bit more. So 2.5 equals my first term, times, so 2 cubed is going to be 8. So I get 2.5 equals A sub 1 times 8, but once again, I'm trying to find my first term, so I got to get rid of this 8. Since I'm multiplying, the way I get rid of it is by doing the opposite of multiplication, which in this case, opposite of multiplication is division. So I'm going to divide by 8 on both sides, those cancel. So I'm going to get that my first term is going to be 0.3125. There you go. So the first term of that particular sequence is 0.3125. Cool. All right, so that's looking at specific terms of geometric sequences. So similar to arithmetic sequences, we started looking at arithmetic series, which meant I was taking each of those successive terms and I was adding them together. We can also look at some geometric series. All right, so geometric series, the sum of the terms in a geometric sequence. So again, series means you are taking those terms and you are finding the sum, or you are adding all those terms up. But sometimes when you've got a list of, say they said find the sum of the first 30 terms, it takes a while to say this plus this plus this plus this plus this. So similar to arithmetic series, they give me an equation that I can use here. So to find the sum of the first n terms in my geometric series, I can use this. Now this one's not as pretty as the arithmetic one, but it's really not that bad. All right, so first thing we need to do here, so it says find the sum of the first 8 terms in this particular geometric series. And I know it's a series because it looks like I'm adding my terms together. All right, so to find the sum of the first 8 terms, let's go ahead and write that out. So the sum, let's just write out my equation so I've got it to look at. So sum of my first n terms is my first term minus my first term times my common ratio raised to the nth power over 1 minus my common ratio. All right, so let's just fill in the pieces we know, and I might have to actually go find something. All right, so I'm looking for the sum of the first 14 terms. Sorry, sum of the first 8 terms. So I know my first term, looking at here, is going to be 14 minus my first term times. All right, now this is where I got to find. I got to find my common ratio because right now I don't know it. All right, so to do that, I'm going to take my second term, which is negative 70, and divide it by my first term, which is 14. So negative 70 divided by 14 is going to give me a common ratio of negative 5. So that's my common ratio here. So I've got my first term minus my first term times my common ratio, which is negative 5, raised to the, since I'm finding the first 8 terms, my n value here is 8. Go back to blue. All over the denominator, I have 1 minus my common ratio, which is negative 5. All right. So that's what we've got so far. It's just a matter of plugging everything in. So the only thing I really needed to find here, other than my first term, which they gave me, was my common ratio, which, remember, just took my second term divided by my first term. So negative 7 divided by 14, I got negative 5. So that's where I got this negative 5 from. All right, so now let's just go through and simplify. So I've got negative 5 raised to the 8th power. So negative 5 to the 8th power, let's go ahead and write this out. We got 14 minus 14 times. So negative 5 to the 8th power is going to be 390,625. Just writing everything out all over. So 1 minus negative 5 is 1 plus 5, which is going to give me 6. All right, so let's go through and simplify a little bit more. Again, let's just kind of show you guys where we're getting our numbers from. So we got 14 minus. So if I take negative 14, so negative 14 times 390,625. I'm going to get negative 5468750. 8750. So it's actually 5,468,750. All that divided by 6. So if I take 14 minus that 5 million number and divide it by 6, that's going to give me negative 911,456. That's the sum of the first 8 terms. All right? So what I want you guys to do is try the second one. All right, so I hope they had a second or so to try this problem. All right, now this one's a little more difficult because they don't actually ask for a particular number of terms. So I don't actually know how many terms I have here. So notice it goes dot, 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 and then it gives me this last term right here to stop at. So this is my first term, my second term, third, fourth, fifth, etc., etc. All right, now if they want me to find the sum of my geometric series, that means I'm going back and I'm using this particular equation again. So sum, first n terms, my first term minus my first term times my common ratio raised to the nth power all over 1 minus r. Again, that's for geometric series. All right, so I got to find, so my first term I know is 1/4. Now to make this a little bit easier, I know 1/4 is 0.25, so I'm just going to write that as 0.25 minus 0.25 times. Now, I've got to know what my common ratio is. So let's just kind of right up here to the top right, let's just look for my common ratio. So then I can take my second term, which is 2/4, divide it by my first term, which is 1/4. But again, instead of dividing by a fraction, let's multiply by the reciprocal. So that's 2/4 times the reciprocal of 1/4, that's 4/1. My 4's cancel, so I'm left with 2/1, which is just going to be 2. So my common ratio is 2 raised to the, now, I have to know how many terms I actually have here. To do that, what I want to do is I want to make sure I put some of the exponents here. So I know that this is 2 squared, 2 cubed. I'm going to have 2 to the 4th, 2 to the 5th. So let's kind of work backwards. So that's 2 cubed, 2 squared, 2 to the 1st, 2 to the 0th power. All right? So that's where it's, so if I work backwards, again, I got 3, then 2, then 1, then 0. So this actually represents 2 to the 0, which remember is 1. All right, so if we look at it, I'm going from 0 to 1 to 2 to 3 all the way up to 14. So some people would say, oh, that means there's 14 terms. No, it doesn't. There are actually 15 terms here. So if I count the 0, that's my first term. So if I go from 0 up to 14, that actually is 15 terms, not 14 terms. From 1 to 14 is 14. From 0 to 14 represents 15. So my n value is the sum of the first 15 terms. So my n value is 15 over 1 minus my common ratio here is 2. All right. So if we go through, if we simplify a little bit, just a wee bit here. All right, so I've got my 0.25 minus 0.25 times. Now 2 to the 15th power is going to be 32,768. All that over 1 minus 2, which is going to be a negative 1. All right. So now let's take 0.25, multiply it by 32,768. When I do that, I get 0.25 minus, I get 8,192, all over negative 1. All right, when I subtract that, I get negative 8191.75. And if I divide that by negative 1, negative divided by positive is a positive, or sorry, negative divided by negative is a positive number. So the sum of my first 15 terms of that sequence is positive 8191.75. So that's the sum of the first 15 terms. And again, they didn't tell me 15 terms. I just had to deduce that from my list here from my series. All right. So that's the sum of the first 15 terms of that particular geometric series. Now, we looked at geometric sequences, finding a particular term. That's that first equation we looked at. We've now looked at geometric series, so we're looking at a number of terms that are being added together. All right, so I found that sum. Now what I want to look at here, this next little piece, and this will be the last thing that we look at, is called the sum of an infinite geometric series. All right, now the key here is that your R value, your common ratio, the absolute value of that common ratio has to be less than 1. All right, which means your common ratio is point something. All right, there's this 0 point something. All right, so it can't be anything 1 or larger. Or sorry, it can't be anything greater than 1, because if it is greater than 1, then that particular sum does not exist. Basically, what we're looking at with an infinite geometric series, when my R value is less than 1, is we're looking to see what number that sum is approaching. All right, and to find that, this one's a little bit easier. It's just your first term divided by 1 minus your common ratio. So this might look like, if we looked at a particular example, all right, right down here below it, says find the sum of the series. Now, that last problem we looked at, we saw a dot, 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 and they gave me the last term to look at. So I used that last term to figure out how many terms there were. But if you notice, this particular series, it ends in dot, 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 which means they're telling me, hey, I don't want you to end anywhere. I want you to keep going to infinity. That makes this an infinite geometric series. All right? So to find the infinite geometric series, again, we use my first term divided by 1 minus my common ratio. All right, so let's look at that. All right, so I know it's infinite, again, because it just gives me dot, 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 which means they want me to keep going up to my infinity-ith term. Don't know if infinity-ith is an actual word, but it is now. All right, so let's find the sum of this infinite series. All right, so that means I'm going to have my first term divided by 1 minus r. Now, my first term is 2. So it's 2 over 1 minus. Now, I got to find my common ratio. All right, so once again, to find my common ratio, I'm just going to do that right over here. It's my second term, which is negative 1/2, so top left, so negative 1/2, first term divided by, so my second term divided by my first term, which is 2. Or I'm going to call it 2 over 1. All right, so remember, fraction divided by a fraction, and then multiplied by the reciprocal. So I got negative 1/2 times the reciprocal of 2 over 1 is 1 over 2. All right, so if I multiply, I'm going to multiply fractions straight across, so I get negative 1 over 4. So my common ratio here is negative 1/4. All right, so I'm going to call that negative 0.25 just for ease. So it's going to be 1 minus, parentheses, negative 0.25. All right. So I got my first term divided by 1 minus my common ratio. So my first term is 2 over. Now 1 minus a negative 0.25 is 1 plus 0.25, which will be 1.25. And then 2 divided by 1.25 is 1.6. So this particular infinite geometric series, if I keep adding each successive term to this series, eventually I will get so close to 1.6, it's going to be like 1.5999999999999, and so it's just going to get so close to 1.6. That's what my sum will eventually add up to be. It never will actually be 1.6, but that's where it approaches. That's the limit it will get to, is right around 1.6. So we'll call the sum of this infinite geometric series to be approximately 1.6. All right. Cool. So that's how you find the sum of the infinite geometric series. We're actually not going to look at this last problem here. Whoop, whoop. All right. So that's it. So now this is going to be your homework tonight. So you guys can look at this, and actually you've also got a review to look at, 11-2, 11-3 review. So we'll probably be doing that. These are just some extra problems for you guys who are just your overachievers, you guys who really want to make sure you know material well. You can use these book pages and these problems to help you there, but Mrs. Miller has a review for you guys. All right, but that's it for 11-1 to 11-3 geometric sequences and series. we're planning on having your test on Tuesday of next week. So please, please, please make sure you are working on your reviews. You're checking your answer keys online. You're asking any questions you have to Mrs. Miller. When I come back on Monday, we'll kind of go over any other questions you guys have, wrap it up, and then your test will be on Tuesday when I get back. So hope you guys are doing well. Look forward to seeing you guys next week. Hope you guys have a wonderful rest of the week, and I will see you guys next week.